This is 3D in Review, where we talk about the latest in all 3D news, as well as interviews, tutorials, and the latest projects from the tech closet. If this is your first time listening, please make sure to subscribe on your favorite podcast app or YouTube.
Hey everybody, hi, this is Mike Balzer from All Things 3D, 3D in Review, and Owl Creek Technologies, and I've got a special guest today. I've got Thomas, hopefully I say this correctly, Appéré?
Yeah, Thomas Appéré.
Appéré, thank you. And as you can see, I've got on my panel here X, or as we would like to call it Twitter again, but essentially this is his page there, and this is how I was introduced to him, by his fascinating images of Mars. And as you may have seen some of my own videos on YouTube, you may have known that I've tried to recreate a lot of the scenes of Ingenuity and the tiny little helicopter for a VR experience that I've been working on, and that's how I saw some of his images, and I was really fascinated and impressed because, you know, as others who are doing the same thing, I like exceptionally looking images. As you can see here, here's one of his latest. I know it's a pinned one. I don't know when he put that up there, but it's really nice. In fact, I use one of these. This is actually one of the later, and we can talk about that later. But he's done quite a few other things that I looked up, and I'm going to let him talk more about that. If I seem a little interrupted in my talk, I've got some echo going on. Let's see if I can bring that down, but it helps me hear Thomas in the future, so I went ahead and turned that down. But as you can see, he's got a great page, and then I'll put all these in the show note links. But then if you go out to Instagram, you'll see a lot more of his images that he has put together. In fact, he's got a few of the Ingenuity. This looks like an interesting one, a laser cut. Do you have that one with you, Thomas?
Yeah, just next to me, yeah.
So, and then he's got a big model of a Lego version that he's going to show us later on too. So I like those that are crafty. Very cool. Okay, so on that note, let me go ahead and bring him up. Hi, Thomas. So why don't you tell us a little bit about yourself? What's your profession, and what do you do for fun? Obviously, you've got all these models here, so I'm assuming, and I noticed you've got an electronic keyboard there, so maybe you can play us a tune.
Yeah, maybe. Hi,
okay,
Mike.
So go for it.
It's a great pleasure to be with you here tonight. It's the night for me in France. So yeah, it's a great time to be here and to speak with you about my work. I'm Thomas Appéré, and I'm a physics and chemistry and also computer science teacher here in France, in Brittany. And I'm I enjoy a lot, as you said, processing pictures taken by Martian rovers, but also by spacecraft. And I'm a self-taught amateur, so I learned by myself all these techniques. I do this hobby for 15 years maybe. So yeah, back to the Mars exploration rovers, and I also enjoy a lot speaking about space exploration during outreach conferences. So yeah, that's my hobby, space exploration.
Hobby, and obviously you're making some money off of it too, or at least providing others education on your experience and expertise. So I noticed in my little research that you have a PhD, and you did a PhD paper on Mars climate and water cycles. And as we know with Ingenuity, that has been a great, well, actually Curiosity as well. These have been very important. So could you tell us a little bit about your paper and maybe how it applies to the two Mars rover missions? So I'm going to go ahead and bring up this first one that you've got, which is Geysers.
Yeah, exactly. So this is an artist image, an artist illustration of what's going on in the high latitudes of Mars on the north and south seasonal polar cap. So my PhD thesis was about these polar caps, these seasonal polar caps, and basically it was about what quantity of water ice is in these seasonal polar caps. Actually, on Mars, the atmosphere is composed mainly of CO2, sorry, 96% of CO2 gas, and during winter, this CO2 gas will condenses on top of the surface in the form of CO2 ice, and it's special ice. It's a slab of ice, actually, a transparent slab of ice, which allows the sun, the ray, to penetrate the ice, and it will hit the surface beneath the ice, and the CO2 ice will sublimate, transform into gas, and the pressure will accumulate, and suddenly you will have a release of the pressure in the form of gas and dust transported from the surface on top of the ice in the form of geysers, as we see on this artist illustration. So I worked a bit about these geysers, but mostly about the water ice in the seasonal polar caps, to understand what quantity of water ice is incorporated in these seasonal ices, and how is it involved in the water cycle of Mars, actually.
That's very interesting. Now, have they found anything like this? What
mean,
particular
on
area,
Mars?
geographic area of Mars, would you see something like this?
We see some geysers, but from above and not in live, actually. We only observe the resulting patterns of dust deposited by the geysers. We never observed a geyser in live. We don't have any spacecraft, any rovers or landers in the southern or northern latitudes. You can remember the Mars Solar Lander, which was expected to land in these latitudes but never reached the surface. But we don't observe them live, but we observe from the orbit of Mars the patterns made by these geysers. So we know there are some geysers, and it's really fascinating physical processes. We don't have these on Earth, actually. Maybe on Triton, the moon of Neptune, but not on Earth.
Oh, interesting. So the other thing is observing weather patterns. So I'll bring up this image. You show, I guess, one of the polar caps and the differences.
Exactly, yeah.
So give us a little detail on that.
Yeah, on the left you have the northern permanent polar cap. So this is a 3 kilometer thick glacier, actually, which is made mostly of water ice and a bit of dust. It's always there in summer and in the course of all the seasons. On the right you have a seasonal polar cap. I prefer to call them seasonal ices, seasonal condensates, because it's not really a cap, actually, and it's composed of CO2 ice mostly, and also of a small part of water ice. And during my PhD, we worked on some data to try to understand how much of water ice is there on Mars. And we obtained the value of 0.05 wet%. So it's a really small value, but it's really important in terms of spectral signature that we observe from the orbit.
Yeah, and that's very interesting. And I think I remember reading that in Scientific American a few years back. So it's interesting. I've known you from your images, but clearly I may have known you also from your writings and your research. So let's see. So there's something called hyperspectral remote imaging. I don't know if we're actually there yet. Let's see what we've got here. I think you've got a few more images of...
Oh, this is a cool animation. Yeah, I can comment it. It's based on Marquis and TESS data, so from Spectrometer data, from thermal images. And with these images, infrared images, you can detect where there is ice and where there is no ice. And you can put these images into animations, into movies. And here you have on the left the North Polar Cap, on the right the South Polar Cap, and you see Mars breathing. Actually, it's like on the Earth, where you see snow depositing on the North Hemisphere, then on the Southern Hemisphere. Here is the same. You have CO2 ice, seasonal CO2 ice depositing, and then sublimating, and then it's the opposite on the opposite hemisphere, actually.
That's very, now how, obviously this is an animation, but it appears not in real time. So what's the progression of time that we're seeing this spread?
The year on Mars is twice as long as on Earth, so it's about 668 Earth days. So a season, a winter season, for example, on Mars is twice as long as winter on Earth. So here, from the beginning of the expansion of this white area to the recession of it, you have 2 seasons. You have you have winter and then spring. And during summer you don't have ice. During fall it begins to deposit. So you have 2 seasons. So it's one terrestrial year, one Earth year. Yeah.
Oh, okay. So it's a fairly great length of time, but it's very cool that we're able to capture this, and obviously the importance of getting some type of, well, I'm kind of getting ahead of myself. Let's move on to some of the other images you have. And these appear to be actual images taken on Mars. Is this correct?
Yes, not on Mars, but actually on Earth in the lab where I used to work during my PhD. These are pictures of one of my colleagues' experiments. And what she did here is to reproduce the ice on the kind of ice there is on Mars. So this is CO2 ice. This is dry ice actually, but not
carbon dioxide, correct?
Carbon dioxide ice. Yes, exactly. It's not fluffy or the kind of snow we can have as a carbon dioxide ice here on Earth. It's a slab, what we call a slab. This is some really large grains of ice, and they form non-porous ice. Actually, all the voids are filled by ice, and you have no air in this kind of slabs. And you observe on the three pictures here some kind of progression between. I think the first one there was you obtain the slab ice, and then you illuminate, you bring some heat on it, and you see a kind of sublimation of the top layer. So yeah, it's really interesting to reproduce this kind of ice on the Earth. It's quite fascinating to know that we can obtain the same ice as on Mars, and to study its signature, spectral signatures, and so on.
Well, that was very important in the development of the cameras that they put on the rovers as well, is duplicating the environment and atmosphere so that they actually work. So, I read a little bit, and I can't think of the person behind the MassCam zine, but he's got a great paper too that's very fascinating. Let's move on to the next image here, which I'm assuming is the same chamber.
Exactly, yeah. And it's really related to my PhD thesis, because during my PhD I didn't work on experiments. It was a colleague of mine who worked on this, but I studied what we observed from the orbit, and from the orbit we observed that some water ice is progressively building on top of CO2 ice, some seasonal water ice, forming a little layer of about 1 millimeter on top of CO2 ice. And we wanted to reproduce that during our experiment, and that's what we obtained. And here it's a bit different. It's what we obtain when we let the CO2 ice forming a slab. So on the left you have the figure A. So you have some white ice, some snow actually, and on beneath it you have some transparent ice, and the transparent ice is progressively increasing in terms of in volume, and the snow is decreasing. It's also I think that we are heating the snow. We bring some heat, so the level of the snow is decreasing, and we see that the slab is progressively building up. So it's we are trying to reproduce also the kind of behavior of the ice during winter and at the beginning of spring on Mars.
Very interesting. So, sticking with this for a moment, we've experimented and created essentially what we think is the formation of, as you said, dry ice on Mars. Do you know of a mission that is going to be going to the polars to actually detect this in real life?
Not no, I not in the future plans of neither NASA or ESA. The Mars program is really stick to the Mars sample return. It's really what is important here is to bring samples back from Mars to study them in our terrestrial labs. So the life on Mars, ancient life on Mars, so with a big question mark, is what drives the Mars missions today, the Mars programs.
Right.
And all of the stuff about the seasonal power caps and things like that, it's not as important as the search for possible ancient life or present life on Mars. We have to wait. We have to wait for other opportunities. Space missions are really expensive. So
I was going to say it's the dollar value, and right now, obviously, discovering life seems to generate, at least in this country's congressional budgets. Life, we'll pay for it, but want to know more about carbon dioxide, snow? No, not so much. But speaking of that, if you want, we can talk about it a little bit later. Obviously, the next component, the ingenuity, is gathering samples, and I actually put together a little 3D model too of it, drilling a core sample. But they're laying these on Mars to be picked up later on by a joint project between NASA and ESA, right? Or ESA? Is that correct?
ESA, yeah.
And
ESA.
There's been some delays with that, hasn't there? Or
there have been some discussion between the Congress and NASA, because the Congress doesn't want to spend too much money on Mars sample return, and there are a lot of a big increase in the cost of Mars sample return. And the problem is that so the Congress said, okay, we won't put more money than what is expected to the NASA programs, but there are other missions than Mars sample return, such as Da Vinci, Veritas, where there are collaboration between Europe and the US. So Mars sample return is actually taking money from other programs. And it's a big deal in the community, because in the science community, because some people know some delays for their missions, for Venus missions in particular, it's not great to have to maybe not cancel missions, but at least delays them. And there are some windows where you can launch a mission, and if you have to wait another window,
exactly.
and so on, it's not good. Yeah.
Yeah, it's disappointing, but the climate changes here on Earth, maybe different priorities.
It's another issue. It's another issue, yeah.
Okay. All right, well, let's move on to the next item. Here we go. Let's talk about this a little bit. The Visible and Near IR Imaging Spectrometer, and what was the purpose of this?
So that's the technology actually which is behind all the results I obtained during my PhD. An amazing tool is hyperspectral and multispectral actually imaging. It consists in observing the surface of a stellar body of a planet, for example, or a moon, with an imaging spectrometer. So it's a spectrometer which provides a spectrum. It scatters. You have the light, the radiations of the whole visible or infrared spectrum for each wavelength, but you have this spectrum for each pixel of an image. And it's really interesting. You have the same kind of spectrum for astrophysics. For example, in some observatories, there are some hyperspectral imagers to observe some exoplanets, and you can have some spectra for different locations on the exoplanets. You don't have as many pixels as for Mars, obviously, but it's really a powerful tool.
Yeah, and not to bring up geez, I've already forgotten the name, Perseverance again, but the MassCam G, and they also have special filters in front of it, specifically to look for certain elements and metallic properties. So I'm assuming it's very similar to what we're seeing here.
It's similar, but you just have far less wavelengths to probe. It's kind of filters, actually. It works like filters you put in front of the camera, and so you let only the light of this specific wavelength to go through the filter. Yeah, and only this wave, and then you obtain several images of the target at several wavelengths, and you can have a raw spectrum of the target. So yeah, it gives some informations on the rock. For example, is it olivine, or is it a basalt, or is it something else? And here on Mars, actually, you have very strong signature of ice. The ice has a really strong spectral signatures, and it's really cool. It's really great because you can obtain some great results about the physical state of the elements of CO2 or H2 ice. You can obtain also some informations about how the ices are mixed. For example, do you have some patches of ice and some patches of defrosted soil? You can compute how much of the terrain is defrosted. There are a lot of information you can obtain with just one spectrum. So it's it's gold for the physicist. Yeah, and you see there are some wide range of spatial resolution from 360 meters to 5 kilometers. We have a wide resolution with omega on Mars Express because of the orbit of Mars Express. It has a high elliptical orbit around Mars, and it's really not the same as the US missions, or the NASA missions, which orbits Mars always at the same altitude, kind of polar altitude. Because the goal of Mars Express was to study a lot of things about Mars, from the ionosphere to the surface. So we needed to study some good resolution for the surface, and so we needed to be far from Mars to study it globally. And it's really interesting.
Very interesting. Okay, let's see what else we have here. Oh, Space Treasure Hunter. What is that?
Yeah, this Space Treasure Hunter actually refers to the fact that every space mission, every rovers, every landers takes a lot of images. If you go to Curiosity or Perseverance raw images pages, so you just type on Google Curiosity raw images or Perseverance, and I just tried. For Curiosity, you have a total of 580,000 images, and for Perseverance, 280,000 results. So we have a wealth of images And you know, NASA will publish just a little bit of these images. Well, I mean, they will publish press releases where they stitch together pictures to form a panorama, to obtain panorama. Yeah, this is the pages I was mentioning. And there are many other pictures which are published in the form of raw images, but they are not processed in the form of other panoramas. So there are many panoramas hidden in this library, I would say. And it's the same for Voyager, it's the same for Cassini-Huygens, it's the same for, I don't know, Hayabusa for the Japanese missions, and so on. You have a lot of pictures, really cool pictures that just wait to be processed.
Agreed.
And that's what I like.
And as mentioned as we started this, that's how I came upon your images, because I have spent a great deal of time in this website. Plus there's this cool downloading script tool that essentially you just tag a bunch of images and then it downloads them for you, which you probably have something similar. And going back to this, you can tell that they must have realized people were doing that, because down at the bottom you have the download option, so you can now do multiple at once. So if you don't have a script to do that.
I know an engineer working at NASA for the Europa Clipper mission. He's a flight engineer, and actually I met him back this summer. I visited the GPL this summer, and I met, so he's Ryan Kinnett, an engineer at JPL, and he developed his own website, which takes all these
What was his name again?
Ryan Kinnett.
Yes, I also follow him. He has a great website.
He's on Twitter, on X. Yeah. And he developed his own website, and it's really useful because you have all these pictures one by one, as on the raw images website of NASA, and you just click on the pictures you want and download, actually, and you have you don't have the images, you have the web addresses of the images, and that's why that's what I am interested in, because I wrote my own scripts on a programming language. It's IGL, it's a language I used during my PhD, and so my script will download the raw pictures, and they will be processed with several tools. I will remove the artifacts made by dust on the sensor. I will crop, for example, the pictures to remove some bad pixels on the borders. So there are many steps. I can
talk about this
on these pictures. So this is the final product. But I sent you some a folder with image processing. You have step 1, step 2, and so on.
Okay, let's see. Okay, I've got them. So let's start with step 1.
Yeah, let's start with step 1. So here you have a caption of what we saw just a few minutes before. So this is a caption of the raw images webpage of JPL for Perseverance. And here you have some pictures taken by the navigation camera of Perseverance, NavCam. We see that some pictures seems to stitch together to form a wider panorama. So I download these pictures. Could you continue?
I will.
Go ahead to the next one. Yeah. So here, this is the first step of my script. It will stitch together 4 pictures. So it's 2 times 2, 4 by 4 actually, pictures to obtain the larger panorama. And here you have all the images that are taken by NavCam. What is important to know is that NavCam has a really large sensor. I think it's 5,120 pixels by times 2,560 pixels.
Yeah, it's a 2 to 1.
So 2 to 1. and they divided it in 4 images, maybe for the bandwidth or something like that. And so then you have to stitch together to obtain the whole image. And so could you go ahead?
Sure. Let's see. I'm trying to stay ahead of you to have you have an inset on doing these while we're going.
Yeah.
Okay.
So between the 2 images, maybe you saw that the color is a bit different. It's because I took into account the calibration of the camera to do some kind of white balancing. And also, we didn't see this step, but I applied vignetting correction. Actually, there is some vignetting on the border of the picture. It's a really common problem on cameras, on digital cameras. So you don't have the same quantity of light coming from the center of the image and the borders of the image. So you just have to apply a flat field to your image to compensate for that. We see a bit the difference. Yeah, we see the difference between the 2 pictures. So these are several steps I apply to my in my processing pipeline. And
so
then,
what color temperature? You said you did white balancing. If you've looked at some of my images, I use something more that I liken to gray balancing because, frankly, if people work with the 2 extremes, white and black balancing, they have a very contrasty image. But if you work with the more the mid or gray balancing, you can get better results. Is that what you're doing here, or you
actually, I worked with Simeon Schmoss, who is a German student working. He's doing a PhD. Actually, he's a PhD student, and we worked together about this color calibration. It's really difficult thing for NavCam. Actually, the only good calibration for colors was done for Insight cameras. There is a paper published on it because in this paper you read that they converted the RGB quantities for each pixel into the XYZ space, the XYZ color space. And then back with they applied the calibration of the instrument and then back to the RGB pixel. So you have to take into account also the gamma correction when you apply all this processing. So it's if you want to do this correctly, you have to be really careful. And here, when I say white balancing, it's about what is white on the picture. So, for example, here you have the pixel instrument on the right, the X-ray spectrometer, which is white. Actually, on Earth you will see it white, and I'm assuming on Mars you will also see it white. Okay, so even if the lightning is a bit redder, after a while, after some time spent on Mars, actually, I guess that you will see it more whitish than reddish. So
you mean you're talking about the human perception being involved here, where we would adjust instead of a standard mechanical process.
Exactly.
And
I had a discussion about that with Doug Ellison. Maybe you know him.
I'm sorry, say it again.
Doug Ellison, Douglas Ellison. He's the founder of Unmanned Spaceflight Forum on the web. It's a forum where you have a lot of discussions about all the space missions. And Doug Ellison is now an engineer at JPL. He's working on NavCam. He's leading actually the team of engineers for NavCam for Curiosity mission. And we had a discussion about the color of Mars. And it's a really hot topic because everybody is providing his own color scale or color hue. So he told me that what we should do is to reproduce a kind of Martian surface and put some scientists in it and just wait for a few hours and just ask them what color do you see. If you know, they will have a kind of grid to match. Okay, so here you see this color or this color or this color or this. What rock is it? What rock is it? Okay, so yeah, his guess is that after a few minutes or a few hours, our brain would adapt to the environmental color or the hue of the light on Mars, and that what we observe in some experiment on Earth, if, for example,
well, if you remember, there was that viral image of the blue gold dress. Remember that?
Exactly. Yeah. Exactly. That's
so
what I
you know.
Yeah.
It's called it's a perceptual vision, and clearly, what I find, and there's been some studies in a paper on, if some people who have regained sight, and how they have to relearn what color processing is. And clearly cultures also have the same issue as well. So that's why I kind of rely on mechanical processes because they're objective, and if you know that this particular wavelength is supposed to be this, then you just kind of balance from that. Something that I don't see in your image here, but obviously you're familiar with it. And did you say these were from the MassCam Z, or were these done from the engineering camera, which is 4 quadrants or up to 16? Do you remember which one I'm talking about? Because normally you see the halo or the gradation in the top left and right corners. So I think that's... And do you stitch these manually yourself, or do you use an application to do that?
To change the color?
I mean, as you mentioned, let's go back to the first one you have here. There are different, it all depends on which ones they put up. They can be either 4 quadrants or 16 images to make up. And they're normally from, and I can't read that from here, it's not the MassCam Z, it's the engineering camera.
Yeah, you have NavCam and...
NavCam, yes.
NavCam, yeah. This is NavCam.
Right. And you may have mentioned that. I apologize. As mentioned, I have some hearing problems, so it makes it a little more difficult to do these things. Okay. But getting back to this, I have found that I can stitch these better manually, but there's a program that Microsoft created, which is no longer available, that does a fairly decent job.
ICE, you mean?
I'm sorry?
Microsoft ICE. Microsoft ICE, ICE.
Yes.
Yeah.
Which I've heard a lot of people, and you can still find it. Do you use that application or some application, or do you do it manually?
I do it not manually, but with a script which puts all the pictures at the correct place. Actually, it's just a matter of what is the pixel of the top left, what is the position of the top left pixel for each picture. And when you know that, you create a new blank picture, and you put all the good the 4 pictures at their good place, and it's okay. It works. So
you have no
there was a problem
artifacts, because each of them would also have, or do you apply the masking? You mentioned it earlier. Before each of the images?
There was a problem at the beginning of the mission. Maybe you noticed it. It was about the exposure of each individual image for these 2x2 NavCam pictures. The problem is that you didn't have the same exposure for each tile, actually. And it was corrected by the engineers at JPL for the public raw images webpage. So now you have the same exposure for each tile. So it's really cool, because we don't have to correct it manually. Well,
good for them, because yes, that was a problem. And I spend about a half hour to an hour each one doing it manually, and I found that sometimes
I was doing it on Photoshop actually with exposure tool, I think.
Well, thank you on that. Maybe if you've got a folder, I can put it in the show notes as a link to anybody else who wants to try this using your techniques.
Okay.
All right, let's move on to the next one here.
Yeah, let's move on
Step
to the
4.
next one.
So
step
this
4
is a panoramic.
stitching. It's a panoramic, yeah. I'm using PTGui tool. It's software, PTGui Pro, actually. It's a software. It's not a free software, but it's worth its price, actually. It's working really well. You can, and what I like in this software compared to Microsoft ICE, for example, Microsoft ICE, is that you can mask some parts of some tiles of some pictures, so that you can choose what picture you prefer. For example, oh, okay, I want to see this part of the instrument on this image and not from the other image. And it's important on panoramics because you have a lot of parallax.
Yes.
And so you can stitch the horizon and the rover, the deck rovers as well. You can't match both together. So it's really difficult. And you have to
you're right,
make
it is
some
very
choices.
difficult. And because of the parallax, it creates distortion. So if you wanted to match the horizon, then your spacecraft is. So what I have done,
it's distorted. And
go ahead. Sorry.
What I do is I prefer stitching the horizon so that you don't have some mismatch, and then I try to do as the best as I can for the rover. And so if you have some discrepancies, I will hide a part of an image. And for example, here I will choose the pixel instrument, the big white instrument you see, and the drill. Okay, I will choose the drill for this for the 1, 2, 3, 4, 5, fifth image. But not the drill from the other image, which is behind it. So, yeah, it's a question of choice.
Okay,
and you see also that you have some differences in exposure between each image.
I was going to mention that, but I've noticed in step 5, which I'll go ahead and bring up, you've corrected for
the
this.
tool. Yeah, it's corrected. Actually, the Panorama tool is correcting it, but it's not shown here on the slide just before. But here you see that it's good, and this is the final result I obtained on Photoshop. So one major step is to increase the saturation, because for NavCam I noticed that the pictures don't have enough
dynamic range.
Dynamic range, exactly. That's it. So I increased the saturation, and it's better. So the red are redder, and
and I do the same, but I do that through the gray balancing, which allows me to expand the dynamic range. Then I don't artificially.
And you can work on the gamma as well. Yeah.
So,
and here,
sadly, I can't remember his name, but what I have found is that the Zcam actually has 10 bits dynamic range, but it's truncated, so the images we get are only 8-bit. And I'm saying, why don't you provide us all 10 bits and let us, because it would be very helpful for this. But
yeah, if only we had 10 bits. They record in 10 bits, I think. Yeah.
I'm sorry.
I think they record data in 10 or 11 bits. I think it's something like this.
Yes, it's 10. They do have some raw. They just don't make it available to us.
Yeah. At least we have some PNG format.
Exactly, not JPEGs.
We don't have JPEG because it's horrible with all these artifacts.
I totally. You know, we can sit here and kind of moan and groan of what we wish we had, but the real point, and I've made this before in some posts, is that we now have the ability, almost in real time, to experience through the eyes of these cameras, which are far better than mine now at 65, that we didn't have in the past. And even Curiosity, which has been there for 10 years now, still provides vistas that not even what's his name, Ridley Scott, can produce for us. So
Yeah.
we've got some tremendous capabilities now, and even some, obviously slow either 2.5 or 5 frames per second videos that we've been able to capture. In fact, the one that they just did of Ingenuity was just fantastic. And I'm going to do a post later on. As you may be aware of, I'm trying to recreate this in VR. So I've created some videos, and one of them looks very much like the way that it went up and down, and I had to take a double take. Wait, was that my video or their video? So it's kind of funny to do that. So yes, these are very tremendous. Now, the other question I have for you, you're doing all these from one camera. Have you tried to do this with both cameras to create stereo?
I tried it for curiosity, for the left and right navcam, to do some anaglyphs. I didn't had time actually to explore all the VR stuff and all the all the reconstruction you can obtain you can do to obtain a 3D terrain. There are colleagues of mine called Gwenaël Caravaca and François Sivet. François actually founded. He's a CEO of a company called VR2 Planets. He was a scientist before actually, and so he became the CEO of this company, whose goal is to create some VR products for the French Space Agency, the CNES. And these products are, for example, a reproduction of a modeling of the Perseverance rover in a 3D terrain. You can have some Rosetta mission in on Churyumov-Gerasimenko comet. So we reproduced all the comet in 3D, and so it's really an immersive experiment. I'm sure you know it very well.
Actually, I do not. So please provide me a link to it, and I'll look it up.
I will provide
Thank
you the
you.
link of his company.
Yeah. So hopefully you're taking a list of all the links, and I'll make sure they're in the show notes when I release this on Friday.
Yeah, it's a French company, but he obtained a prize for during a scientific conference because of the quality of his modeling, and I send you his link. He also worked on Insight, and Gwenaël Caravaca actually is working on the same kind of modeling to study scientifically the scene on Mars. So, for example, he studied which was it? It was it's a place studied by Curiosity. I don't have the name. Never mind. So he studied all the layers deposited during the watery past of Mars, and what was really interesting is that it was like a ground truth. I mean, the VR made possible to be on Mars virtually, and to study the layering, to measure with a virtual how do you call it?
Calipers?
Calipers, to measure the distance between the layers and stuff like that. So yeah, it has actually a scientific interest. It's a scientific tool, actually, VR now. So we are in a new era for studying data, not only on our screen in 2D dimension, but it's really a 3D dimension. We entered the Martian terrains to study it, and maybe you saw some movies or some clips from NASA where we see some scientists putting some HoloLens or Microsoft HoloLens, I think.
Yeah, I remember when they first announced a HoloLens, they had a demo where you walked on Mars, so maybe he was part of that. And even in my own experience, I've been using photogrammetry to actually take composites of the different, like the landing site and a few others, so that when I release it, you will be actually walking on as close as you can get to the terrain. So fully aware of the potential there. In fact, I worked with a company called Occipital where we created a 3D scanner, and one of the potentials, even, what was it, back in 2013, almost 10 years ago, is to take this, now that we have essentially LiDAR in our pocket if you've got an Apple iPhone, take that and scan objects or use photogrammetry, and then you can come back and, as you say, measure very closely what something would be away from the site. So not only can we take back samples, but even if you couldn't, we can at least take back three-dimensionality imaging that we can then further study things. So and now we're able to do it remotely from planets further away.
Yeah, it's it's so important for a geologist to be on the ground, actually, because from I remember a discussion I had with a friend of mine. We did our PhD at the same time. She was a geologist, and she is a geologist actually. She told me what is frustrating with Martian pictures is that you see them, you see orbit pictures, or you see pictures from rovers, but you are not on the ground to have the perception of distances, and even with 3D and glasses, it's not the same as being on the ground in situ. So VR is really a great tool, and photogrammetry as well, to provide.
Well, I've been doing my part. I've been pushing the Zcam team and also the camera that's on the end of the arm to be used very similar to photogrammetry, where you shift the camera, and because they can create precise patterns. So I've actually seen them starting to do that. So that gives us the ability to take those images and bring them into a photogrammetry tool to create these objects that the geologist needs. So if you're starting to see more and more of that, I'm not going to take credit for it. Obviously, there are a few people who are pushing it.
On the website Sketchfab, you have a lot of
yes, I do.
3D models.
Yeah, and there's another individual who actually has been working with them who has a lot of 3D models as well that are very excellent. I can't think of his name right now. But yes, him and I have discussed this, and so we've kind of pushed JPL to start putting in a program function, especially around their drill sites, because then you can take that information and create photogrammetry, and I've noticed more and more 3D models that seem to be more precise. So hopefully us kind of poking them a little bit has helped in that area, but totally agree. I think that is the future, and we're seeing more and more imaging being taken with that in mind, where you're just shifting the camera in order to provide parallaxing needed for photogrammetry. All right, let's go back and to those images that you had before, and let's talk about them briefly. What do we have here?
Yeah. So here it's a picture I processed back in a few years ago, actually, because it's a Sol 953 for Curiosity rover. So back during the first 1,000 sols of Curiosity. Now we are closing to the 4,000 sols. And what I like in this picture is that you have a really special lighting. It's during the golden hour on Mars, and you see really well the relief, the texture actually of the soil, all the rocks, all their shadows, the hills behind the footprints of Mansharp. It's really beautiful, actually. Yeah, and
so is this a composite as well?
It's no, it's a color picture of MassCam. Actually, it's a MassCam. I think it's MassCam 110. Yeah.
Okay.
MassCam right, actually, and I'm trying with all these pictures. I'm trying to do some kind of postcards, as if we were there and you were on Mars. You take your smartphone and you take a picture of the scene, you see, oh, yeah, oh, it's really beautiful. The sunset is really beautiful, and you take a picture, and that's what you obtain. I'm trying to make
Duplicate
the
that.
viewer having this experiment.
Well, it's beautiful, and the detail. One of the things that I've noticed that you obviously can't get with an iPhone is because this appears to be since the MassCam has a zoom lens, seems like it's more or less in the telephoto area because the background, I think, is artificially closer due to that, which makes it look even more ominous or actually very surreal and beautiful.
Yeah, it's a telephoto. 110 focal length. It's a good zoom.
It is.
We had on Curiosity. Yeah.
Yeah, it's wonderful when they do that, and also because you have the left-right images, it really works well if you stitch well, or actually just bring them in and use. I can't remember what I use now, but there's a couple of great photogrammetry tools that, when they sequence those out correctly, you can really get some very beautiful.
There is so much to do on these data from the Mars rovers in terms of photogrammetry. Actually, there is so much more to do. We could recreate almost all the traverse of Curiosity rover in 3D with all the data, the MassCam data, for example. There.
Well, even I can't remember the cameras in front, and I'm sorry.
HazCam maybe.
The HazCams, the front HazCams also provide stereo. In fact, they presented a video that actually showed the 3D terrain that they have available, and I kind of begged them, said, please make that available because that would be great to provide that 3D terrain for what I'm doing. But sadly, I don't have the big enough voice for that yet. So let's move on to the next item. Let's see, what do we have here?
Okay. So it was I sent you this picture to illustrate another kind of processing I do. As I'm a teacher, it's my job, so I love to illustrate correctly what we see on Mars. And what I mean when I'm saying correctly is with the scale. Here, I added the scale 5 millimeter to the two pictures, to the two subsets, so that we can have a sense of scale for these rocks. It's a big issue actually on Mars with the pictures, is that we don't know if this rock is big or small because we don't have known elements to compare with. It was the same issue during Apollo missions. Astronauts on the moon, they thought that it would need, I don't know, maybe 30 minutes to reach this crater, but actually it was it needed not 30 minutes but 1 hour to reach the crater because it was more distant than what they thought because of the lack of elements of known elements to compare.
Lack of references, plus unlike Earth, which has an atmosphere which helps.
Exactly.
You don't have that on, so it's, and here we have a very low.
The atmosphere scatters light, and you have this difference in colors. And here on Mars, it's the same. I'm studying Mars for 10 years actually, or 15 years even, for my processing, for my image processing. But I still don't know exactly what size is this rock, and usually I underestimate the size of the rocks. It's always bigger than what I thought. So here, what you see is a rock which was crushed by a wheel of Curiosity. So it shows the interior of the rock. You see that it's a gray, whitish, grayish rock. And the right pictures, the left picture is taken by MassCam, and the right pictures are taken by Mali camera, which is at the end of the robotic arm. And you see all the little grains composing this rock. So you have different scale to study Mars with Curiosity rover. and it's really a treasure for geologists here on Earth studying Mars. Yeah.
Yeah, so I'm assuming in order to provide your referencing, you know the magnification of the lens itself, but more importantly, if you look in the top left inset, you actually have part of Perseverance there, correct? In that image?
Here it's Curiosity rover.
Oh, okay. But
And
still, you
yeah,
have a mechanical
yeah.
component, and because you know the exact measurement of that
Oh, yeah,
component,
yeah,
you can
yeah.
use that in reference.
Yeah, sorry, I had my camera screen, the screen copying my camera, which was on top of the top left image. So yeah, we see the robotic arm and part of the rover, but it's on the foreground. It's not at the same place actually than the rock. So yeah, it's not exactly useful to estimate the size. But to assess the size of these rocks, sometimes you have the wheel of the rover, which
Right.
is really close to the rocks. So you can estimate the size, but you have to know what is the size of the wheel. And the wheels are so large. During this summer, I took a piece of the not Curiosity wheel, the same size as Curiosity wheel. I took one of them, and it's really large. So yeah,
Yeah,
it's
but then
difficult to
also, well,
to
especially with the
estimate it.
Perseverance, you've got the tread, and that's all.
Mhm.
I mean, you can find a lot of the engineering mechanicals for all that. So if you know all of these and they're
Yeah,
in your image, all you need to know then is the optics, and then
yeah,
combining the two, you can come up with it. You were
yeah,
talking, we were talking about photogrammetry. This other person said there, I'll put his name in the show notes with a link, who has a number of his 3D models. He puts three-dimensional rulers and objects in there to give you
yeah,
scale too. So very good on his part as well to identify
yeah.
that. So,
Rulers are good. Yeah, yeah.
so
It's a good way to assess to
yeah, I'll
estimate the
send you a
size.
link. He's got some excellent
Yeah.
models.
Okay. Great.
Okay, so let's move on to this one. This one, I think you were trying to imitate a certain American black and white photographer, huh?
Yeah.
Ansel
I
Adams.
I I love the fact that Curiosity navcams are taking some white and some black and white pictures. On Perseverance, the navcams are color cameras, but back on Curiosity, it's a black and white cameras, and it gives really special characteristic to the picture. Actually, it's really special, and I love the scenery we obtain with this. It's a
Well,
dramatic landscape,
the
actually.
MassCam actually can take, well, obviously
Yeah,
none of them are black and white. I don't know what
yeah.
the spectral resolution of this particular, the HazCam is, or the NavCam, but I know
Here
the
for the
NavCam,
knife cam,
I'm sorry?
yeah, just an information is that for the knife cam, the sensor is going a bit into the infrared. So it explains why here Mount Sharp is really bright and not as bright. It's less bright on the MassCam pictures, on the MassCam bright black and white pictures. It's because it's composed of dust on top. The surface is composed of dust and of sulfates, which are bright in the infrared. So
Hmm.
that's why you see it brighter than the terrain next to Curiosity rover. Yeah.
So as I was mentioning, the Zcam has the filters, and and it does have two or three that are in the infrared
Hmm.
as well. And they are available. Obviously, that's not what people gravitate to. I've tried to
Yeah.
use them because in creating 3D models, you're probably familiar with physical base rendering, where you can
Hmm.
do roughness and metallic. So I've been using
Yeah.
those other images to composite a PBR spectrum. So then I know how much metal as well as other things. So I created a table from that, and it's worked out well so far. So
Okay.
yes, so it's not
Great.
the snow cap that we have there.
No, it's not a snow cap. No, it's just
Do-
minerals, bright minerals in infrared. Yeah.
okay, so here's another. And again, you are trying to bring these in with a photographic eye, and I really find them impressive. So what do we have here? This is Curiosity,
Yes.
as well as the
Yeah,
previous
here
one.
it's also Curiosity with kind of a mountain. It's not a mountain actually; it's just a hill, about I think 10 meters high. And what was challenging here was to reconstruct the sky. One of the tasks I try to do when I'm processing pictures is to expand the sky vertically to obtain what I call a postcard. And I think it's really important to obtain an immersive image. And here, the picture was taken with the sun in front of the river. So it was hard to obtain good details in the shadowy part of the hill, and to stitch all these pictures together. There were a lot of different exposures between all the pictures composing these mosaics. So we don't see it's a mosaic, but actually it's a mosaic of NavCam
You did an
pictures.
excellent job. I mean, I'm not looking at
it
the
was
full
it was really
detailed
challenging
image, but
actually.
the balance is really nice. How many images altogether of this mosaic?
Good question. I can try to find it back on my computer. Up. Oh, just wait a minute. No, it's not here. Up, it was. So I'm looking on my Flickr page. It's it's a social media for photographs. And okay, I have the picture here. 10 pictures. It's 10 pictures. The scenery was imaged at 2:50 p.m. Martian local time. So at the beginning of the Martian afternoon. And it was back in 2021, yeah.
Very impressive. And also looks like in the background there, do we have a dust storm? Or
I don't think so. On the background you have the wall of Gale crater, and it's kind of hazy, but maybe it's because of the difference of exposure between the light and the overexposed pictures because of the sun. And we see on the right side of the picture, we see a distant mountain behind the wall of Gale crater. And if we see this mountain, it means it's not a mountain actually. It's I think it's the side of a crater, the wall of another crater outside Gale crater. If we see this feature, it means that the sky is pretty clear, pretty clean. Yeah. Okay. So
very impressive.
There is no dust storm during this when this picture was taken.
So let's bring in another image from Curiosity.
Yeah, I love this picture. It's it was taken on, I think it's morning. Yeah, I think it's the morning. It's not the evening. It's during the golden hour on Mars. I will just find the exact reference of this picture. So you have on the left you have Kukkonen Hill, and on the right you have another hill which is really smaller than Kukkonen Hill. Kukkonen Hill on the left is 100 meter high, and on the right you have another hill. I don't have the name of it. It's about maybe 10-12 meters high, and it's the morning. It's a sunrise here on Mars, Martian sunrise. It was 7 a.m. On Mars, and you have some really beautiful lighting. And I chose this picture because Abigail Freeman, who is a deputy manager of Curiosity rover. She printed this picture and she put it on her desk at JPL. So it was really an honor to know that people from the mission like my processing, and even put it on their in the room where they work. So yeah, it was great.
Cool. Very
Yeah.
cool. Okay, well, let's jump to a more recent series of images, Ingenuity, and I was hoping to go just an hour, so I don't want to speed you up, but maybe kind of run through these a little closer. Looks like a image from Ingenuity.
A few comments. Yeah, it's a picture, one of the several pictures taken by Ingenuity. So here there are a lot of steps in the processing to distort the image. It's the pictures are taken by camera which has a really short focal length. So you have to distort it, and you have to correct the vignetting, and you have to correct the color. And after all these steps, you obtain this kind of pictures. I also extended the sky in post-processing. And what you see...
I'm going to go ahead and zoom in because I think I know which image this is.
It's difficult to see. You have a hill here at the center of the picture. You have
there
tracks
it is.
you can follow. And you have Perseverance rover.
There
Perseverance
it is.
rover, a bit like Wall-E, actually. It's a bit like the Wall-E robot.
That's what I was thinking too. In fact, I think I put an image that had Wall-E next to it. It's kind of fun.
Yeah.
Looks like Wall-E.
And behind, well, actually in front of Perseverance rover, you have Belva crater. No, not this way, the other way, on top of the image. In front of the rover, actually, he's looking at it. It's Belva crater, the white crater, which is
right
at the background of the picture. Yeah, you can even zoom out to see it correctly. Yeah, it's on the right of the picture. Yeah, it's this white crater. It's 900 meter large, and there is a dune field at the bottom of it. So Perseverance didn't explore this crater, but it was quite an amazing landscape to see. And thanks to Ingenuity, we have this special view from 10 meters high, so it's really great. Yeah.
Yeah, it's been spectacular. Again, the combination of perseverance and ingenuity, what we've been able to accomplish and delight our own eyes with to be part of it. A lot of people have made comments that we need to send people to Mars, and I don't really agree with that. I think the budget necessary to keep people alive, if they could, there's obviously some mixed opinions about that, if they would even survive going to Mars. To me, as a human, how is this different than Neil Armstrong or Buzz Aldrin taking pictures? I mean, it gives me the same experience, and then also because you have multiple spectrals, we can see a lot more. And as AI gets better and better, I think this is the direction we should go, frankly. That's my opinion.
Yeah.
I don't agree with Elon Musk cowboys in space attitude.
No, I don't agree. I don't agree neither with him on his plans, actually.
So what's sad though is that, as you're probably aware, of Ingenuity was built with a lot of off-the-shelf components. I think that was a custom lens on this, but the sensor is still basically a Sony. What did I look it up? It's like the Sony sensor from an iPhone 4.
Yeah.
And obviously what we've been able to accomplish with it has been significant, but because of the dust, and frankly, I think we're starting to see some degradation in the lens.
Yeah.
Even
definitely,
though in post I've been able to clean up, it's getting worse and worse. And obviously 57 days versus where we're at, or 51 days. We're still getting great images, but nothing as pristine as these.
No, it's a technological demonstrator, so as a sojourner on Mars Pathfinder.
Yeah, it was
it
only
was not
supposed
supposed to last that long.
5 mission or flights.
3 or 5 flights, I think. It's
5.
It's amazing.
Yeah.
We
So-
have 55 flights.
I know.
Now.
Isn't that amazing?
Amazing. Yeah.
And I keep saying, well, I'm not going to release Ingenuity in VR until it's dead, but
Yeah.
it keeps surprising me. Yeah.
You know that actually Gwenal Caravaca, who is now working at in Toulouse in the Perseverance mission, he used some pictures taken by Ingenuity to do some photogrammetry when Ingenuity arrived at the top of the delta, when he just flight when he arrived at the top of the delta, he took a lot of pictures, and one next to the other one, and you could do some photogrammetry with it. So he did it, and we saw the little dunes, and it was possible to do some 3D. As for the for the back shell, it was done for the back shell when Ingenuity flew over it, and it was used by the scientific team to assess if
you're talking about the
was it interesting to study this particular outcrop, or was it preferable to go ahead and so the last option was chosen, not studying this outcrop, but go to the Belva crater. Ingenuity was not only used as a pathfinder, but also as a scientific tool to assess the scientific what was interesting of the terrain.
Yeah, I don't know if how long you followed my Twitter, but I think it's been about a year now. I used it's called I can't even remember it. Apple has some photogrammetry tools, so I pushed a lot of the early images from the MassCam on Ingenuity into it to create the 3D terrain, and actually caught the attention of the lead engineer. Now they were only grayscale, but I colorized them, but it gave you terrain, and then the individual you just mentioned took that and kind of ran with it and combined it with some of the images from the main camera, and now you see the results.
Yeah.
So it's really fun to watch what would you consider us as amateur enthusiasts bring to the table, and then see them apply these.
And you know, when you put these VR tools in the hands of young students, it's amazing. They love it, actually, and it's a really good tool to bring them to STEM, to science, to technology, and so on. It's really a really brilliant tool. Yeah,
I think the money that went into Ingenuity and obviously Curiosity and Perseverance is far exceeded its budget as far as education and information. I'm a big proponent in robots, and I think as they get smarter, they're just going to be more and more valuable. And I think all this money being wasted to create environments for people to get to these is silly in my opinion, but I've said that before. All right, let's move on to this Perseverance image.
Okay, so more recent pictures from the Perseverance mission, actually. It was taken when Perseverance was heading to the Delta, and we have also here again pictures taken during the morning. I love this hour because it's the golden hour, actually. It's when you have the perfect lighting to see the landscape, and so we have on the foreground all these volcanic rocks, basalt, and so on, and then you have dunes, and then you have the delta about I think it was 50 meters high about, and then on the background you have the wall of Geysers crater. So yeah, really nice.
Yeah, it's a very impressive.
Really
obviously, the atmosphere is clear on this particular day. So let me ask you, how many? First of all, what's this mosaic consist of? How many images?
How many images? Good question. I will find it quickly, I think, because it's taken at the beginning of the mission. Perseverance, Traverse to the Delta. Yeah, it's actually I think it was a lot of pictures. Oh, I have processed so many pictures, it's difficult to find. I'm not sure I will find the.
Well, again, I will praise you on your ability to blend them without seams. You do an excellent job in that area, and I do like the choices in the color temperature and your balancing. Obviously,
Yeah, it's the fact there is no seams. It's thanks to the software PTGuy Pro. It's really powerful, and also manual adjustments on the software to improve the results. And then for the color balance, I think it's after many hours processing it and looking at NASA products and images from the orbit, from the surface, I think that my eye can catch a good color balance, and but if there is some budget to send me to Mars, I will tell you if it's a good color balance or not.
so what are you processing these on? I specifically purchased a more expensive monitor that one had a 10-bit gamut, but also had the full sRGB color spectrum. Are you running these on a nice monitor, or?
I bought an Asus monitor. When I bought it a few years ago, it's not really recent, but I tried to buy one which was really how do we say, which was good to display colors. And I also have a MacBook Pro, which is 10 years old, actually 11 years old. So Apple products are really good to last. And the screen of the Apple products are, I think, they are good products. So they reproduce the color pretty good, and for the picture you were displaying, it's 14 pictures taken by MassCam G left at 6:50 a.m. Martian local time.
So do you think that they're doing this intentionally to catch this specifically for you, Thomas?
So no, definitely not.
So why do you think they're capturing them early in the morning like that?
I think it's for having a good sense of how many rocks are they on the terrain, of the geologists. They like watching the terrain when during this golden hour because it's better to see the difference in colors between each rock, while when it's 12 p.m. You don't have this shadow. You have less shadows, and you don't see as many colors as here. So it's really good to see the rugosity of the soil, the dunes. So I think it's a scientific choice. Maybe it's also cosmetic choice, but I don't think so. I discussed with Doug Ellison during my visit of the JPL, and he told me that they are trying some new techniques or some new slots to take pictures, time slots. For example, to acquire pictures early in the morning for curiosity, and that's how they discovered we can see some noctilucent clouds in the sky of Mars. We saw them from the orbit, but now we can see them from the surface because they decided to try to image the sky early in the morning.
That makes sense.
It's and Doug he loves processing pictures. That's how he began being involved in the Mars missions of the rover. So yeah, he has this. I think he's advocating for taking pictures, not just for engineering, but also for
aesthetic purposes.
outreach reasons. Yeah, yeah.
Yeah, I'm trying to remember. The actual camera, the MassCam Z, was, I think most of the work was done out of, what is it, the University of Arizona? Was that correct? ASU?
MassCam Z, it's a good question.
Yeah,
University of
I'm
Arizona
pretty sure
is-
that's correct. I just can't remember his name. That's who
Yeah.
I've had a few conversations with. He's got an excellent paper, which I'll also put in the show
It's
notes.
Jim Bell, no? Jim
yes,
Bell is the
that-
PI of this team.
Yeah, so I've spoken to him, or not spoken, I've written to him a few times, and he's replied. Yeah, it's amazing what that camera is capable of doing. I guess I'm kind
Yes,
of
that's it,
a
yeah.
little bit
Arizona
of
State University, exactly, yeah.
a photo gearhead. So let's move on. What do we have here?
Oh, yeah. So it was to show that I'm interested not only on the Martian surface, but also on the other cosmic treasure we have, actually, like this picture from Rosetta, the European mission which explored the Churyumov-Gerasimenko comet. And here we have an amazing cliff of ice and dust imaged by, I think it was Osiris camera. And yeah, it's totally not from the Earth, I would say. You have the blackness of space.
Yep.
The sky is black. You have these rocks, which are not rocks, but which are made of ice and rocks, actually. And the gravity is completely different, really low, really small, actually. And so you see these rocks, these boulders, which fell from the cliff, probably because of the thermal stress between the day and night, and the sun hitting the ice, and the ice sublimates. You have all these processes. So yeah, this picture is brings a lot of scientific information on the comet, but also it's really beautiful in terms of an extraterrestrial landscape.
It is. Fascinating. Okay, moving on. This is kind of interesting. So not only have you spent a lot of time on Mars, but you've also been working on this.
Yeah, on Titan. So this picture was made by a friend of mine, Stéphane Lemoelik, working in Nantes, in France, in a laboratory of planetology, of planetary science. And here you have, at the center of the picture, is Titan, as you will see with your own eyes, with human eyes. And the 6 pictures around it are what we will see if we could see through the clouds and through the methane windows. Actually, in the atmosphere of Titan, Titan is the biggest moon of Saturn. It's about 750,000 miles away from the Earth, more than 1 million kilometers. Right? So it's larger than Mercury. It's important to know. It's larger than the smallest planet of the solar system. And its atmosphere is composed mostly of nitrogen, but also of methane and ethane, 1%, about 1.6%, and also of organic haze. So what you see in yellow, it's a haze. The same kind of haze that you have in London, for example, or in the big cities when it's polluted.
Smog.
And so it's made of organics, toluenes, we call them toluenes. Really interesting in terms of chemistry, because it mimics, it looks like the kind of chemistry we had on Earth when it was really young. And the surface is really cold. It's minus 190 degrees Celsius, so minus 290 degrees Fahrenheit. And what you see on the surface with your infrared eyes, I would say, it's dunes in brown. It's ice in bluish, in whitish and bluish surface. And also, what is really blue, it's also ice, but more pure ice, water ice actually. And on the poles of, on the polar regions of Titan, what is really interesting is that you have lakes and seas, and not lakes and seas of water, but lakes and seas of methane and ethane. So what is fascinating with this moon is that you have a methane cycle with clouds, rain, and yeah, it's really interesting.
Yeah, it's dramatic.
Yeah, dramatic, yeah, totally.
So, and this is interesting.
Yeah, so it's about discovery we made during my postdoc about 10 years ago. I was working with Sébastien Rodriguez in Paris, and so he gathered some observations by VIMS. VIMS was the hyperspectral spectrometer about the Cassini spacecraft orbiting Titan, or orbiting Saturn actually, which made some flybys of Titan. And during the flyby, we observed some arrears which were brighter in some particular wavelengths, and we couldn't explain it just with the classical modeling of the atmosphere. So what we did was to model the atmosphere, the radiative transfer through the atmosphere, and we obtained a good match by including some dust, organic dust actually, in the atmosphere, but some big amount of organic dust. So the conclusion was that during particular days, there was some organic haze storms, some dust storms of organic material on Titan, and this is what is shown here on this drawing of Titan, on this artistic illustration.
So was this 3D rendered, or was it just a composite of multiple?
Here I think it's just yeah, not maybe a composite of drawing of 3D 3D modeling of the surface, but mostly some drawing of or mixing of a drawing of Saturn and a dust storm. It's not me who did this illustration. I was not actually I was not more I was no more in the lab when the paper was accepted by a Nature journal, so I was not aware of all the latest the last processes for the publication. But if you look at the foreground, you can see that you have twice the same rock and twice the same patch of soil, of bright soil. So I think it was cloned to make it was photoshopped to make the surface. The idea was just to say, okay, so here's what would a dust storm on Titan look like.
I see right here too.
Yeah, you see?
Oh, now you've ruined it for me.
It.
Teasing. Okay,
So
last
it's
item
Titan
here.
photoshopped. And here it's the observation actually. It's what we observed with our data. So these are infrared observations. We did some RGB, and by choosing 3 channels in the infrared, these 3 channels are in infrared windows. What we call window actually it's oh, I don't have the word. It's a range of wavelengths where you can see the surface, because methane is an absorber in the infrared, but it has some bands of absorption, and between all these windows of absorption, you have windows where you see the surface. So we observe the features on the surface here. And what we can see is that the arrow is pointing at features that appear in pink, and these are the dust storms. You see? Here there is nothing, and here up the dust storm is appearing. So you have it on January the 12th and no more on January the 20th. And the same for other period of time in June 2010. Okay, so June 21, you have the storm, and then if you continue the animation, the storm has disappeared. And it's not a cloud of methane in the atmosphere, clearly, because it's not the same spectral signature. To reproduce the spectral signature, you have to include some organic haze in your model. So and what is great with the spectral signature is that you can assess you can obtain the size of the organic haze. You can obtain the quantity of organic haze, the opacity actually of the cloud, and also the altitude of the cloud. So there are many information which can be obtained
just by the spectral signature.
This data. Sorry?
Just from the spectral signature.
Just from the spectral signature, yeah. It's the same from the James Webb Space Telescope, actually. A lot of astronomers were more interested in looking at the spectral data than the amazing images. Because the spectral
and also
data...
all those that people are amazed by the Webb are all falsely colored to begin with. So.
Yeah. The images, they are good for outreach because it's I agree, it's amazing all the details we see, but for the scientist who needs some more information on the physical and chemical processes occurring in the atmosphere, for example, of exoplanets, the spectral data is really important, and you need some a good sampling of spectral data. And also a good resolution. You have to have a good signal-to-noise ratio for each wavelength. So it's a nice
obviously
time
very
to
fascinating.
do science.
So make sure when we finish up, you provide links to all of your research. If you've got any papers that have been published, I'd like to have those too. And then a lot of the names that you mentioned. Sadly, some of them I didn't catch. If you would like to provide me a link so that we can get them in the show notes. But let's talk about one more thing before we close up, and that is I see a lot of entertaining models behind you. And then before we started this, you had two models of Ingenuity. One was a Lego. If you want to go ahead and present that to us, your Legos. Oh, you've got Ingenuity too.
I have a huge collection of Legos. There are also some of them, just above me. A lot of rockets.
I can't pan your camera.
Show them. And here you have an Ingenuity model in Lego. Actually, it was designed by the same NASA engineer who designed the Curiosity model, who is somewhere, not the other way, somewhere here in my collection. And so he designed also the Ingenuity model, but it was not chosen in
I think those rotors are a little short.
Yeah, you can rotate.
Oh, how fun!
It's it's amazing. You have the solar panel, you have the antenna, you have all the stuff which is well reproduced. And here you have the baby Ingenuity. So this one, it comes with Perseverance rover, so it's now available in the US. Actually, it was available in Europe before in the US. So here
Wow,
is
that's
the
impressive. So
big
that's
Perseverance model.
Perseverance?
That's Perseverance, yes, exactly. And Ingenuity at the same scale.
Oh, that
So
would make
here you
sense.
can do something that will never happen on Mars. You can put Ingenuity on top of
No, well,
Perseverance.
I've been able to do that in
And
the Unreal Engine.
yeah,
In fact, I
it's a
put one
really
video together, and one of the engineers came back and said that would never happen because I brought it really close.
yeah. You can do it in 3D, but it will never happen, yeah, on Mars. And you can turn the head. You can change the tilting of the head. You can actually manipulate the arm with some tools here, and you can change the way the wheels are, the way it rolls on Mars. Yeah, there are many things to do with this amazing model. So yeah,
So how long did it take you to build it?
a bit more than 6 hours, maybe. Yeah, it's a pretty big model. Yeah.
Yeah, it's pretty detailed. And then you have one that looks like it's made out of laser cut wood
Oh yeah,
pieces.
I also like to build laser cut models like this one. So
Yeah,
it's this one it's also Perseverance. They don't call it Perseverance. They call it I think they put the name Persistence. Persistence. It's not exactly the same.
Well, yeah, because
And
I
you
noticed
have
I'm pretty sure the Perseverance doesn't have that parabolic antenna on it.
yeah, it has a big high gain antenna. So it's not as well detailed as the Lego model, but you have the RTG here actually, and you have this part which is
Yeah.
different on Curiosity and on Perseverance. So yeah, you can identify that it's Perseverance. Actually, the high gain antenna is here.
Mm-hmm.
High gain antenna is here. It's just that you have this
Yeah.
complementary parabolic stuff
Yeah,
to catch
to make it
the
look
TV
cooler.
on Mars. Yeah. Yeah.
Well, I really appreciate you coming on, Thomas. That was fun. So, as mentioned, I'm going to probably don't have to do much editing, but I'm going to release this on Friday. And yeah, it was exciting. Thank you. I know
Yeah,
that
it was a good time.
and
I will share with you the last links.
Okay.
And also the papers. Yeah, the scientific papers, the one I wrote, and I just have a look on my web page, my Google web page, to see if the publications are free. I mean, if you can access them without
paying for them.
yeah, I think it's good. Sometimes you have a paywall, but here it's good.
Yeah.
So it's the one for Titan, and I will send you the link just now for Martian stuff.
Okay.
Up.
Well,
And the last one is yeah, just to so that you can have
okay.
all my publications. So I'm no more how to say a scientist working for a lab. I'm a teacher, but I'm still doing some collaborations. For example, we wrote a paper with a friend of mine who is a scientist working in the east part of France about the raindrops impression on Mars. So we are looking for imprints of raindrops in the clays layers when Mars was covered by water, and so we would try to find if some evidence of rains on Mars would persist. No, if we could find this evidence dating back 3 billion years ago.
Well, that'll be interesting.
Yeah, that would be really interesting.
Okay, so I'm going to sign us out. Well, I want to really appreciate Thomas, Dr. Thomas Appéré. Is that correct?
Yeah, Appéré. It's hard to
Appéré.
say it in English. Yeah.
I apologize for Not
No
getting the
worries.
name right. But I appreciate him coming on and taking the time to go through and show us some of the wonderful images he's created, as well as sharing with us some of the data that he's accumulated about not only on Mars, the weather system, but as well as Titan, which we'll probably see and hear more about in the future too, because I guess that's where they're going to be selling a little helicopter. Maybe in a decade, we'll see another helicopter on Titan. All right, on that note, this is all things 3D in review, and I appreciate you. And, you know, I don't have anything here, but I've been working on a few projects too, and I will be releasing them probably September, October, and I will give you guys a sneak peek at them. All right, thanks, and bye.
This is 3D in Review, where we talk about the latest in all 3D news, as well as interviews, tutorials, and the latest projects from the tech closet. If this is your first time listening, please make sure to subscribe on your favorite podcast app or YouTube.